Hello everyone. Okay, so if you have watched any of my recent videos, you probably noticed that I've been having a bit of trouble with my voice. I'm not sure what's going on, but today it is pretty much all gone, so we'll go the electronic route. Besides, this electronic voice makes me sound smarter. Doesn't it? Hey. Be nice. Alright, the primary purpose for today's video is to cover the performance of my new Lossigy brand battery. I needed to try it out in a real-world test to see how it would hold up. However, to fully understand what I put it through, let's talk about the circumstances surrounding the test. I spent the better part of 4 days camping at an off-grid cabin on the Texas-Mexico border. The solar control system I put together for this test was connected for a total of 91 hours between Sunday, December 15th and Thursday, December 19th. Have you watched the 2 solar build videos I posted? You should. I'll link them in the description below. The picture here makes it look pretty cloudy, and it was for a little while when I first arrived. But the clouds quickly burned off and it was sunny for just about all of the remainder of my daytime hours there. I got to work early on and got the solar control board set up. And then set up the solar panels. I was fortunate to have an electrical connection that allowed me to provide power to the cabin. And I did that via the 1000-watt modified sine wave inverter. Also during my time there, I had to make sure the battery in my pickup would get me home when the time came. So I used the 750-watt Schumacher inverter to run a trickle charger installed in the truck. This only ran for about 4 hours overall but did the trick, and obviously I made it home just fine. And I just want to touch on the Bestech Pure Sine Wave Inverter. While it did work fine to keep a laptop battery topped off, I certainly would not recommend it if you are an amateur radio operator. The RF noise generated by the inverter made radio reception pretty much impossible. But this isn't a review of the Bestech. So moving on. And I just briefly want to mention the other 2 primary components of the solar control board I put together. First is the rich solar charge controller. It is the 40 amp model. It came with a temperature sensor and does temperature compensation based on ambient temperature of a battery compartment. It also has an RS-232 jack that makes it so you can use the Renault G Bluetooth module BT1. And, finally, the PZEM051 LCD digital current, voltage, and power meter. It is not a high-dollar unit, but it does work quite well. Alright, now on with the performance numbers. I will tell you about the primary findings here, but I am putting a document in the description below that goes much more in depth. I know some viewers like longer videos and some would rather I just get to the point and move on. Trust me, that is my preference as well. But you can't please everyone, so I'll be as brief as I can here, and you can read more for yourself if you wish. This was a 4-day excursion with the equipment connected for 91 hours. The battery, as pictured here, is a 12-volt, 280 amp-hour lithium iron phosphate manufactured by Lossigy. In at least one of my recent videos I had mentioned how these are my preferred brand for installation in golf cart battery upgrades I do for my neighbors. This one is of equal build quality, very good, and did not disappoint. The battery was at 100% state of charge at the start of this adventure. When I disconnected in preparation to return home, it was showing a 65.4% state of charge. Overall power usage was 6,120 watt-hours. This was comprised of LED lighting, 672 watt-hours, a 12-volt cooler that ran continuously during the trip, 4,950 watt-hours total, about 4 hours of use of a trickle charger which drew a total of 120 watt-hours, and finally, about 5 hours of amateur radio use. Assuming a duty cycle of 30%, and a transmit current draw of 21 amps, total power usage for the duration came to 378 watt-hours. The solar panels were comprised of 2 100-watt panels, connected in parallel. The panels and the control board provided a total of 4,440 watt-hours during the 91-hour duration. Daylight hours in that area were at just over 10 hours per day, and of that, about 6 hours of useful solar input was experienced. Overall, I was quite pleased with the performance of the solar supply and very happy with the battery performance. Obviously the battery was underutilized on this trip. And that makes me pretty confident that I can rely on it to stand up to more rigorous use in the future. I want to extend my thanks to the Lossigy folks for making this trip and this test a reality. This was a sponsored interaction, but I assure you, no one tells me what to say and there was never any hint of that in our interaction. I actually approached the folks at Lossigy about this since I have purchased their products in the past and have found them to be very well built. I have also strongly urged my neighbors to also go with the Lossigy brand. Spoiler, they have all done as I suggested and none have regretted it. If you like what I am doing, please like, subscribe, comment, and share this video. I enjoy making these and will keep at it as long as folks are willing to watch an old geek with tools. 73 all.